Hello everyone, today I am going to show you how to design a high pass filter with cutoff frequency of 500 Hz. Now to begin with, it is very easy in Multisim to simulate this. Now as we have already set our cutoff frequency as 500 Hz, we can take capacitance value as 1 microfarad and calculating the R value we get R as 318.3 ohm. Now we calculated by using R is equal to 1 by 2 pi fc formula, where f is 500 hertz and c is 1 microfarad. You get 318.3. Now place a virtual resistor over here. We change the value. You can do going to properties, resistance 318.3. Now we need a capacitance of 1 microfarad default value. If you want to change it, you can select it and plus control M. It will, the window will come. You can change whatever you want. Next, in high pass filter, the output is taken across the resistor. In low pass filter, output is taken across the capacitor. We can rotate by selecting and pressing Ctrl R. Now components are placed. We need a function generator which generates different frequencies. We have to test again different set of frequencies. So function generator is here. We need an oscilloscope to determine the waveforms, how much lag is there, how much lag or lead is there, how much change is happening as per the frequency. Now let's connect. Now connect the other part of the resistor to common. Do not connect it to negative because you will get twice the voltage as required. So that's why always connect it to common. Let A be the input waveform to the oscilloscope. Now let B be the output of the circuit to the oscilloscope. Now let us set up the function generator. Initially we will test it for 100 Hz with 50 millivolts peak. It means 100 millivolts peak to peak. 50 millivolts peak. Now let's simulate. We should connect ground before doing anything. Can stop here. Now change the scale to 50 millivolts per division. It is easy to recognize here. Now this is the output coming across the resistor, but the input is somewhat like this. It means the capacitance is not allowing most of the voltages. It is taking most of the voltage. It means resistance. Now as the frequency increases beyond 500 Hz, you can see the changes of high pass filter, how it reacts. Now as of now we have tested against 100 Hz. Let's check it against 500 Hz. For 500 Hz, response is like this. Now as you can see, this is input, this is output. The output has been increased slightly from 100 Hz, from output of 100 Hz. Now as we can see, as frequency increases, the voltage gain is increasing. Now let's check it for 2000 Hz. Now as you can see, input and output are almost coming same. Gain is almost equal to 1. It means at higher frequencies it is allowing the input voltage. Gain is at most 1, gain cannot go beyond 1, but gain is here almost 1. Now for another higher frequency, say for let's check for megahertz, 1 megahertz. For 1 megahertz, I'll set it for 1 megahertz. Run, reduce the time scale. Now as you can see, input and output both have been fixed together. It means they are hiding one behind another. As you can see, there is no such change between input and output. Input and output are as it is. It means both are same. Here the capacitance is now acting as short circuit for higher frequencies. The capacitive reactance formula is, as we know, X is equal to 1 by 2 pi Fc. Now as F increases, F is 10 power 6. It means the reactance is very low. As very low reactance means it is short circuit. Now all the input voltage is coming across R1. So the gain is almost 1. Now let's simulate for AC frequency response. Now uh, go to frequency parameters and set vertical scale as decibel, sweep type as decade. It means it starts like 10 hertz, 20 hertz, 30 hertz, up till 100 hertz. Then from 100 hertz only 100, 200, 300, 400, like this it goes multiple of 10. Save. We need to add parameters at the output, which parameters we are considering as y-axis. We have set v2. Now this resembles the graph of the frequency response graph of high pass filter. Now it is as it is. You can see also the phase change here as the frequency increases. Thank you very much.